In the last class, as I have given two videos, that is sixth one and seventh one, regarding the chapter periodic table, particularly atomic radius, covalent radius and van der Waals radius. And also we have studied in detail about the increase or decrease in the atomic radius of an atom as atomic number increases. The increase in the atomic radius is due to the fact that the addition of extra subshell of an electron and the decrease in the nuclear charge as the distance between the nucleus and the orbitary electron increases. Definitely the nuclear attraction over the electron decreases. Hence the electrons are loosely bonded, so the size of an atom increases. As size of an atom increases as we move from top to bottom in a group, definitely the atomic radius is also goes on increasing. In the other way, as we move from left to right in a period in the periodic table, even though there is a increase in the atomic number, the electrons are added into the same distance. It means the electrons are added into the same subshell. By the way, there is a constant increase in the nuclear charge. The increased nuclear charge succeeds the addition of an electron at the same distance. As a result, electrons are attracted more and more towards the nucleus. Hence, the size of an atom decreases. As the size of an atom decreases, definitely there is a decrease in the atomic radius as we move from left to right in a period in the periodic table is observed. Coming to the one more important aspect in the periodic properties, that is ionic radius, particularly a cationic radius and an ionic radius. Ionic radius, coming to the definition of ionic radius. Ionic radius can be defined as the distance between the nucleus of an ion and the outermost shell containing electron. The ionic radius is defined as the distance between the nucleus of an ion and the outermost shell containing electrons. Here the following figure indicates the radius of a cation. Here I have taken the example of a sodium, its atomic radius as well as its ionic radius. So as the atomic number of sodium is 11, configuration is 1s2, 2s2, 2p6, 3s1. The outermost shell, that is valence shell of sodium, contains one electron, The valence shell of sodium contains one electron in the form of a 3s1. And when we supply an amount of energy in the form of a heat energy or in the form of a light energy, the electron revolving in the outermost orbital will be gets removed from the gaseous isolated atom, forming a cation. The figure indicates the formation of a sodium cation after the removal of a valence electron by applying a certain amount of energy in the form of a heat energy or in the form of a light energy. So here this is the neutral sodium atom having 11 electrons. Out of these 11 electrons, one electron is in the valence shell. After the removal of this valence electron, the neutral sodium atom forms a sodium cation. This is the sodium cation. According to the definition of an ionic radius, the distance between the nucleus of an ion and the outermost shell containing electron is called as a ionic radius. So here this is the ionic radius of a cation, that is sodium. So let us we see one more example indicating the ionic radius of an ion. Coming to the second example, by taking an example of an ion and its radius. To deal with the anionic radius of an ion, here we have to consider the most electronegative atom, that is chlorine atom. I have taken the example of chlorine atom as the atomic number of chlorine is found to be 17. Its configuration is represented as 1s2, 2s2, 2p6, 3s2, 3p5. The valence shell of chlorine contains 5 electrons in the p subshell. So when we add one electron to the chlorine atom, the chlorine neutral atom will be converted into a chlorine anion. The chlorine neutral atom, as indicated in the figure, by the addition of one electron, it will be converted into a chlorine anion. Neutral chlorine atom, by the addition of one electron, it will be converted in the form of an ion. So here the picture itself indicates the atomic radius of a neutral chlorine atom is smaller and that of the anionic radius of a neutral chloride ion is higher than the neutral atom. So anyhow, the ionic radius is defined as the distance between the nucleus and the outermost shell containing an electron. Ionic radius is defined as the distance between the nucleus and the outermost shell containing electron. So this is the anionic radius of a chloride ion. Coming to an example of sodium chloride. As we know, sodium chloride is a crystalline solid. Here in sodium chloride, anion and cation are held by a strong electrostatic force of attraction. In case of sodium chloride, the chlorine the chloride anion and sodium cation are held by a strong electrostatic force of attraction, forming a sodium chloride crystal. If we take such crystal, the distance between the nucleus of cation and the anion can be determined by X-ray diffraction method. The distance is the sum of the ionic radius of the cation and an ion. If the value of any one is known, the value of other can be calculated. Coming to particularly a cation-ionic radius. The cation-ionic radius of cations are smaller than those of corresponding atomic radius of a neutral atom. As I have told already, in case of sodium, the valency electron, that is 3s1 electron, is going to be removed by the supply of certain amount of energy. As this valency electron is removed, the nuclear charge on the nucleus will be increases. By the removal of one electron, the nuclear charge of sodium will be increases, and this indicates the ionic radius of a cation after the removal of one valency electron. After the removal of the electron revolving in the valence shell, no doubt the net nuclear charge on the nucleus of sodium is increases. Here, as the electron is lost due to the formation of cation from the neutral atom, as the valency electron is lost due to the formation of a cation from the neutral atom, the positive nuclear charge increases and the nuclear charge exceeds the net negative charge of electron. So the electron cloud shrinks. As electron cloud shrink, electrons are drawn closer to the nucleus. As electrons are drawn closer to the nucleus, size of the cation decreases. Here, as an electron is removed from the neutral atom, as an electron, that is valency electron, is removed from the neutral atom, it forms a sodium cation. The size of the sodium cation is smaller than that of the neutral sodium atom. As a result, the ionic radius of cation decreases. The decrease in the cationic radius is due to the fact that the electrons are attracted more and more towards the nucleus as nuclear charge increases. Hence, the size of the cation will be decreases. The table indicates the cationic radius of sodium cation and the iron in the form of a ferrous as well as in the form of a ferric ion. That is, from the neutral sodium atom, as we remove one electron, it forms sodium cation. It shows a decrease in the ionic radius of a cation than the neutral sodium atom. The table indicates the value of atomic radius of neutral sodium atom is 1.90 Armstrong unit, whereas that of the sodium cation after the removal of one electron. Its radius is found to be 0.95. So this indicates a decrease in the cationic radius. The another example, coming to the iron, the atomic radius of neutral iron atom is 0.117 Armstrong unit, whereas coming to the ferrous ion, that is which is formed by the removal of two electrons, its cationic radius is found to be 0.076 Armstrong unit, whereas coming to the Fe+3, that is iron ferric ion, which is formed by the removal of 3 electrons. Here more and more nuclear charge is increased, which pulls the orbitary electrons more and more effectively. As a result, size of the +3 cation is again decreases, and it is found to be 0.063 Armstrong units. Coming to the anionic radius, the ionic radius of an ion will be greater than those of the neutral atom. Coming to the anionic radius, the anionic radius of an ion will be greater than those of the neutral atomic radius. For example, here I have taken the chlorine atom, as it contains 7 electrons in the form of a valence shell, that is 5 electrons in the 3p and 2 electrons in the 3s subshell. Totally the valence shell contains 7 electrons. If we add one more electron to the chlorine atom, the neutral chlorine atom, by the addition of one electron, it will be converted into a chloride anion. By the addition of one electron, the neutral chlorine atom will be converted into a chloride anion. As one electron is added to the neutral chlorine atom forming a chloride ion, the net negative charge of an electron will be increases. As the net negative charge increases, the electrons are pulled towards the, as one electron is added to the neutral chlorine atom, the net negative charge over the chlorine will be increases, forming a chloride anion. The increased negative charge expands the size of the anion. As the size expands, the attraction of the nucleus over the electron becomes smaller and smaller. As the nuclear attraction over the electron becomes smaller and smaller, the electron cloud expands. The expansion in the electron cloud is due to the increase in the electronic charge. As a result, the size of the anion will be increases. As the size of the anion increases, definitely there is a increase in the radius of anion is observed. So this diagram indicates the increase in the size of the ionic radius of chloride and ion. The ionic radius of an anion will be greater than that of the neutral atom. This is due to the addition of an electron. Why the atomic radius is greater than that of the neutral atomic radius? So this is because as more and more electrons are added to the atom to form an anion, as more and more electrons are added to the neutral atom forming an anion, the net negative charge increases and the electron cloud expands. As a result, size of the anion increases than the corresponding neutral atom. Hence, ionic radius of anion increases. The figure indicates the neutral chlorine atom, its size and its radius, and size of chloride anion and its radius. So definitely here we are going to observe the size of the chlorine neutral atom is smaller than that of the chloride ion. As more and more electrons are added, the electron cloud expands. As a result, the size of the anion increases. Hence, we observe an increase in the size of the chloride anion. The following values indicates the ionic radius of neutral chlorine atom as well as chloride anion. The atomic radius of neutral chlorine atom is found to be 0.14 Armstrong unit. The atomic radius of neutral chlorine atom is found to be 0.14 Armstrong unit, whereas the ionic radius of chloride anion is found to be 0.18 Armstrong unit. The ionic radius of chloride anion is found to be 0.18 Armstrong unit, which is higher than that of the atomic radius of a chlorine neutral atom. In general, as we move from top to bottom in a group, the ionic radius increases, whereas the ionic radius will decreases as we move from right to left in a period in the periodic table. This is in usual trend as that of the atomic radius. Here the ionic radius also goes on increasing as we move from top to bottom, and it decreases as we move from right to left in a period in the periodic table. In today's class, we have studied regarding the ionic radius of cation and anion and their variation along the group and along a period. In my next class, I am going to explain regarding the factors affecting the size of the atoms and ions.